Okay, one more round of looking at the determination of Laplace transforms by integration. I know that some of the examples have been rather excruciating, for the lack of a better term, but again, I just wanted to provide a bit of a refresher should you decide to go into some mathematics courses that might go beyond differential equations, and you'll have a lot of stuff involving factorials and other modes of integration. And now, for this particular portion, I just wanted to mention how we had the formation of Laplace transforms originating from the terms that we have in the natural logarithmic exponential base e. Okay, so we have with the Laplace transforms, say we have determining the Laplace transforms of e to the 3t as well as e to the negative 2t. And we have with e to the 3t and taking the Laplace transform and setting up in terms of integrating, and we have with the product property of exponents, I can add these powers together, and then factoring out t, I can rewrite this as the integral of e to the quantity of 3 minus s times t dt as t goes from 0 to infinity. And looking for the antiderivative, so if I set up what I have in terms of substitution, okay, so we have with the integral of e to the 3 minus s quantity times t dt, so have setting u equal to the power to which e is raised and applying the differential on both sides. Left side we have with respect to u, right hand side we have with respect to t, where we have dt expressed as du over 3 minus s, and just applying what we have and substituting. Okay, so we have e to the u, and we have times du over 3 minus s, and shifting the reciprocal of 3 minus s out to the front of the integrand. Okay, we have this statement, and now we have the integral of e to the u du. Okay, and we have with back substitution, we have for the initial formation of the antiderivative after back substituting, we have e to the quantity of 3 minus s times t all over 3 minus s followed by the constant. And now we're going to be looking at making this expression into 0 once we apply the limit. So I'm going to put what I have here factoring out negative t. Okay, so I have, and also changing the 3 minus s in terms of s minus 3. So I'm going to be taking the negative of e to the negative t times the quantity of s minus 2 over s minus 3 followed by the constant. And so carrying this antiderivative over. Okay, all right. And we have, again, so we have our integral with the Laplace transform and applying limits in advance, kind of bypassing some of the in-between stages. So we had the limits going from 0 to b as b approaches infinity and putting in the antiderivative. So if I have b to represent t, and I'm taking the negative of b as b approaches infinity, you're going to have e to the negative infinity. And so we have at the upper limit, this will go to 0. And you have subtracting what we have in the lower limit. We have negative times the negative is a positive. E to the 0 is 1. And we have all over s minus 3. So we have for the Laplace transform of e to the 3t, that comes out to 1 over s minus 3. In the case of what we have with f of t equal to e to the negative 2t, have same bit of history, and we have with the product property combining and factoring out t, we have e to the quantity of negative s minus 2 times t dt, and taking what we have and finding out the what we have in terms of substituting. Okay, so we have in this layout, okay, now we got with substitution, okay, so we have u equal to the quantity of negative s minus 2 times t, and for what we have upon substituting, okay, have e to the u times du over negative s minus 2. And we're going to have with back substitution, so you have the negative of e raised to the quantity of negative s minus 2 times t over s plus 2. And technically I'm supposed to add a constant. And like what I did with the previous function, I'm going to factor out negative t. So I'm going to have the negative of e to the negative t times the quantity of s plus 2. So you have with distribution still come out to negative st minus 2t. And with this antiderivative and applying for what I have in the Laplace transform integral, we have carrying over and applying the limits. Okay, so it's going to follow that we have as t approaches b while b approaches infinity. We're going to have the exponent to be approaching e to the, or say negative e to the negative infinity, which is tangent to 0. And we have, again, with t set to 0, we have what's going to be e to the 0 over s plus 2. And so we have minus e to the 0 is going to be plus 1 over s plus 2. So the Laplace transform of e to the negative 2t comes out to 1 over s plus 2. And now just a little bit of a summary here for what you have, say from the Laplace transform table. Anytime you have e raised to an integer power in the variable t, we have e to the at, where a is an integer. So we have e to the at is going to have a Laplace transform where we have the reciprocal of s minus a. So going back to what we had earlier, whenever we had e to the 3t, so we have a represented by 3. And so the Laplace transform comes out to the reciprocal of s minus 3. And when we had e to the negative 2t, your a value is at negative 2. Laplace transform, we have 1 over s minus negative 2, which translates out to the reciprocal of s plus 2.